Let's take a look at the next example in section 1.6. We have f of x equals 2x squared plus 8x plus 4 over radical x. Now one thing we could do is we can split this up as 2x squared over radical x plus 8x over radical x plus 4 over radical x, since we are dividing by a monomial. But that might make things a little more complicated because now we have to worry about subtracting exponents and things like that. So instead, let's use the quotient rule. So for the quotient rule, our numerator will be n of x, and our denominator will be d of x. So however we want to organize it, make some kind of chart, and write down what is n of x equal to and what is n prime x equal to. So n of x is 2x squared plus 8x plus 4. n prime of x, 2 times 2 is 4, so this is 4x. This is x to the first, so 1 times 8 is 8. That'll be 8. The derivative of the constant is 0, so we get 4x plus 8. d of x, this is equal to, remember, square root of x, we need to write that as a rational exponent, so this will be x to the 1/2. And then for d prime of x, the 1/2 is going to come to the front. So we're going to get 1/2 x to the 1/2 minus 1 over 1. We always subtract 1 from the original exponent, so because this is a fraction, I wrote that as 1 over 1. So this is 1/2 x raised to the 1/2 minus 2 over 2 to get a common denominator. So d prime of x is equal to 1/2 x to the negative 1/2. Okay, and because we can't have a negative exponent as part of our answer, we move this x to the negative 1/2 to the denominator. So d prime of x is actually equal to 1 over 2x to the 1/2. And we can leave it like this, or for the sake of making this a little bit easier, I'm going to say that d prime of x equals to 1 over 2 times square root of x. I'm going to convert that back into radical form. And for radical form, the root is the denominator is the root, so we have the second or square root of x. The numerator is the exponent, so x to the first, which we don't have to write. So that's going to be our d prime of x. Now things are going to be a little more complicated because we are going to be dealing with some fractions, but let's take one step at a time. So our formula is right over here. d of x times n prime of x minus n of x d prime of x divided by d of x to the second power. Okay, so let me write that here. We have d of x times n prime of x minus n of x times d prime of x divided by d of x to the second power. Okay, so let's start with the d of x. So d of x, that is equal to x to the 1/2, or square root of x. So f prime of x is equal to d of x, which is square root of x, times n prime of x, which we said here is going to be 4x plus 8, minus n of x. So what is n of x equal to? N of x is this one right here. That's the 2x squared plus 8x plus 4. And we're going to multiply this by d prime of x, which is 1 over 2 radical x. And all of that is going to get divided by d of x to the second power. So d of x is square root of x, and if we take square root of x to the second power, that'll just give us x. So this equals to square root of x times 4x plus 8 minus 2x squared plus 8x plus 4 times 1 over 2 radical x. All of that is going to be divided by x. Now in my open math, this answer will be accepted. So you can enter your answer like this. It does make entering this a little bit complicated, so you just have to be careful. Make sure you use that little like arrow thing, and write this the best you can. You'll need a numerator and a denominator, so make a fraction first, and even on the numerator you'll need another fraction here, so like mess around with it and get the correct way of entering it. Now we want to figure out what is f prime of 2. So for f prime of 2, we're going to take this whole derivative and we're going to plug in 2. So we're going to have radical x, which is radical 2, times, put a bracket here, 4 times x, which is 2, plus 8, and that's going to complete the bracket, minus 2 times x squared, which is 2, plus 8 times 2, plus 4, and then that's going to be times 1 over 2 times the square root of 2. And all of this is going to be over x, which once again is going to be 2. So let's simplify a little bit more. We have radical 2 times 4 times 2 is 8. 8 plus 8 is 16. So this is going to be 16 radical 2 minus, if you simplify this little bracket, 2 squared is 4, and 4 times 2 is 8. So this thing gives us 8. 2 squared is 4. 4 times 2 is 8. 8 plus 2 is 16 plus 4. So this is going to be 24 plus 4, which is 28. And then we're going to multiply that by 1 over 2 radical 2. And all of that is going to be over 2. So let's simplify this even further. 16 times radical 2, that's just going to be 16 radical 2. Now the 28 and the 2, these are going to cross cancel. The 2 goes into itself once, and it goes into 28 14 times. So we're left with minus 14 over radical 2. All of that is going to be divided by 2. This you can put into Desmos, or you can split this up even further. You can split this up as 16 radical 2 over 2 minus 14 over radical 2 all over 2. So let's look at the first one. 16 radical 2 over 2, 16 divided by 2 is 8. So this gives us 8 radical 2. Now if you think way back to algebra, you can't divide a fraction by a fraction. So what we have to do is we have to put a 1 underneath the second denominator, which is a 2 over 1, and multiply by the reciprocal of 2 over 1, which is 1/2. Okay, so if we do that, the 2 over 1, 1/2, they cancel. 2 goes into 14 7 times, and this gives us 7 over radical 2. So essentially what we're doing is we're taking this 14 and we're dividing it by this 2. So 14 divided by 2 will give us 7 over radical 2. And then you can put this in Desmos and come up with a decimal, and remember to round to 4 decimals for the purposes of my open math. Okay, take a look at this. It's a lot of work, kind of tedious, a little complicated. So think of questions you have before class. This example we will save for class. And let's do one more example. You have f of x equals to radical x minus 4 over radical x plus 4. We want to find f prime of 4. So this is our numerator, that's n of x. This is our denominator, that's d of x. So let's make a little chart. And first, let's write down what n of x and d of x equal to. So n of x, and even though it's radical x, I'm going to write that as x to the 1/2 minus 4, because remember we need rational exponents anytime we do derivatives. And then d of x is equal to x to the 1/2 plus 4. Same rationale. We want to write this as a rational exponent. Now, n prime of x, the 1/2 is going to come down, and if you subtract 1/2 minus 1, that gives you a negative 1/2. But we can't have a negative exponent, so we're going to say that n prime of x is equal to 1 over 2x to the 1/2. This moves to the denominator to make the exponent positive. And to make things even more simple, let's take the 1/2, x to the 1/2, and rewrite that as radical form. So that'll be 1 over 2 square root of x. The root is a denominator, so we have a square root. The numerator is the exponent, so it's x to the first. Now we have d of x equals to x to the 1/2 plus 4, and we want to find d prime of x. So this is once again 1/2 x to the negative 1/2. By the same rationale, let's move the negative 1/2 to the denominator. This gives us 1 over 2x to the 1/2. And then x to the 1/2 is just square root of x. So this also gives us 1 over 2 radical x. All right, so it looks like we have the same derivative for the numerator and denominator. Let's now plug this into the formula. Formula is once again d of x times n prime of x minus n of x times d prime of x, all of that, divided by d of x to the second power. Okay, so let's start with the denominator. So to get f prime of x, our denominator, d of x, is radical x plus 4. And we're going to multiply this by n prime of x, which is 1 over 2 radical x, minus n of x, which is radical x minus 4. We're going to multiply this by d prime of x, which is 1 over 2 radical x. And all of that is going to be over d of x squared, which is radical x plus 4 raised to the second power. Now, before we do a lot of simplifying, let's think about what we're actually looking for. We're actually just looking for f prime of 4. So before I start distributing this and all that kind of stuff, let's make things a little bit shorter, because we don't need to simplify in this case because we're only looking for f prime of 4. So once we find the derivative, let's just plug in 4. So this gives us radical 4 plus 4. So remember, x is 4 now. So we're going to say radical 4 plus 4 times 1 over 2 radical 4. So replace this x with the 4, minus radical x, which is, once again, radical 4 minus 4 times 1 over 2 radical 4. So I just replaced every x I saw by 4, and then don't forget the denominator, which is radical 4 plus 4 raised to the second power. Okay, let's keep going. Radical 4 is 2, so this gives us 2 plus 4 times 1 over, this is also 2, so we get 1 over 2 times 2, because once again radical 4 is equal to 2, minus radical 4, which is 2 minus 4, over 1 over times 1 over 2 radical 4, which is 2 times 2. And then all of that is over radical 4, which is 2, plus 4 to the second power. Okay, now let's simplify this. So if you simplify our parentheses, 2 plus 4 is 6 times 1/4 minus 2 minus 4, that's negative 2, times 1/4. All of that is going to be divided by 2 plus 4, which is 6 squared. All right, we're not done. Let's keep going. So 6 times 1/4, use a calculator for that. 6 times 1/4 will give you 1.5, minus negative 2 times 1/4. Again, use a calculator. This will give you negative 0.5. All of that is going to be divided by 6 squared, which is 36. So this gives you a negative and negative. This becomes a positive. 1.5 plus 0.5 is 2. And we get 2 over 36. So you have two choices. You can reduce this and leave your answer as 1 over 18. Or you can leave your answer in a decimal form. So if we take 1 divided by 18, you're going to get 0.0556. And remember to use 4 decimals here. Okay, a lot of numbers, but go through it, rewind the video if you need to, go through it one by one, and figure out where all the numbers are coming from. What you don't understand, come to class with questions. And the last example we will work on in class.